Welcome, Algebra. We are taking a look at Chapter 6, and we are solving inequalities. I think that you are really going to like this. I think you're going to find it very simple, especially compared to what we have been doing. So, as we are working on solving inequalities today, so there we go. We are going to be focusing on using addition and subtraction to solve inequalities today. So for your learning objective or your learning goal, is that I can solve inequalities using addition and subtraction. So that is our focus for today. So let's take a look. When you're graphing inequalities, these are just on a number line because remember, inequalities are going to say that two expressions are not equal. So our inequality symbols could be greater than, less than, greater than or equal to, less than or equal to. So this is kind of going to be your cheat sheet here for how to graph inequalities on a number line. So if we have a quantity such as x that we're saying is less than another number, what I'm going to do to show that that quantity is less than is I'm going to use an open circle, and to show that it's less than the number, I'm going to shade to the left of that line. So for example, if I say that x is less than 3, then on my number line as I graph it, I will put an open circle at 3, and then I'm going to shade to the left. I'm going to use a squiggly line so that you can tell the difference between my shading and my actual number line. So the open circle tells you that x cannot be equal to 3, and the shading shows you that it could be anything less than 3. So as we look at statements such as x is greater than a number, I'm again going to use an open circle, and that open circle is just showing me that that x can't be equal to that number. But then I'm going to shade to the right because x should be greater than that number. So that could look like if we said that x was greater than 2, for example. So if I have 0 and 2 on my number line, I could put an open circle at 2 and then shade to the right, and that's going to show you that x is greater than 2. So the only difference with these next two is that when I use the less than or equal to symbol or the greater than or equal to symbol, now I'm going to use a closed circle. So if I wanted to say that x is less than or equal to -5, then on my number line, and I'm running out of room here, we'll do it right here. If this is 0 and this is -5, then I'm going to put a closed circle at -5, and I'm going to shade everything to the left. Okay, and finally, if I am using the greater than or equal to symbol, the equal to part again tells me I'm going to need a closed circle. So let's say I need to graph x is greater than 10. Then on my number line, I will put a closed circle at 10 to show that my graph is equal to 10, and then I'll shade above to show that it's also everything greater than. So one thing that's important to note is that equivalent inequalities have the same solutions. So we're really going to use all the same rules, mostly the same rules, for inequalities as we use for equations. So for example, when I say x is less than 2, this has the same solution as this equality, x plus 4 is less than 6. And that's because if I use inverse operations to solve this inequality for x, then I get back to the same inequality as I have over here. So that's important to note that these both would have the same solution. So let's try some more out. On your homework, you're going to be given graphs and have to write the inequality that goes with it, and vice versa. So when we're given a graph and we need to write the inequality, it doesn't matter which variable you choose, but we need to look at the type of circle used and the direction of the shading. So I have filled in the circle at 10 and shaded everything to the left. So my solution, or the value of my variable, is equal to 10 and everything that's less than 10. So I will say x is less than or equal to 10. On part B, I have an open circle at 5, so that means I'm not including 5, but I have shaded everything greater. So x is greater than 5, but not including 5. And on part C, I have a closed circle at 3, and I've shaded everything above. Or I'm sorry, -3. So x is greater than or equal to -3. And on part D, I have an open circle at 50, and I've shaded everything to the left. So x, or whatever variable I pick, is less than 50, but does not include 50, so I don't put the equal to part. Now, if you are given an inequality and you're asked to solve and graph it, then we need to use inverse operations to get the variable by itself and then solve and graph. So for letter A, I have -4 is less than 2 plus y. So just like with equations, I want to get the variable by itself. If I want y all alone on this side of the inequality, I need to get rid of the 2. So I will start by subtracting 2 from both sides. -4 minus 2 is -6. 2 and -2 are inverses, so those cancel to 0, so all I'm left with is y. So now notice this is written in the opposite order, but look at the part of the sign that is facing the variable. So this could be rewritten as y is greater than -6 because the greater part of the sign is touching the y. So as we graph this then, at -6, I'm going to use an open circle because I'm not including, y is not equal to -6, but it is everything greater than. So I'm going to shade above -6. All right, on part B, we have d minus 3 and 8/10 is less than or equal to -6 and 2/10. So again, to solve, I need to get d by itself. So I will add 3.2, or I'm sorry, 3.8 or 3 and 8/10 to both sides. And as I subtract -6 and 2/10, I have a -6 and 2/10, so I'm going to add 3 and 8/10 to it. I am still going to be in the negatives at 2 and 4/10. So to graph this one, at 2 and 4/10, I'm going to go ahead and put a closed circle because I need to include -2 and 4/10 as part of my solution set. And then I'm going to shade everything less than or to the left. And finally, on C, I have x plus 3 and 1/4 is less than 8. I'm going to solve for x, so I need to get rid of 3 and 1/4, so I'll subtract it from both sides. So I end up with x is less than 4 and 3/4. So at 4 and 3/4, I'm going to put an open circle because x cannot be equal to 4 3/4, and it does need to be less than all of those values that are less than 4 3/4 would be part of my solution set. Okay, you also will need to know how to take a verbal sentence, write, solve, and graph an inequality. So when we say the speed limit is 35 miles per hour, we mean that you can go 35 or you could go less than 35, but you can't go above. So as an inequality, that would be x is less than or equal to 35, because it is okay to go 35. So when I graph it then, at 35, I'm going to use that closed circle to show that I'm including 35 and shade everything less than or to the left. On part B, the sum of 13 and m is greater than or equal to 5. So the first thing I see is sum, so I automatically know that I'm adding, and the two numbers I'm adding are 13 and m. So 13 plus m is greater than or equal to 5. So in this case, I've written an inequality that I will need to solve now. So to get m by itself, I'm going to subtract 13 from both sides. Just like an equation, I have to keep my inequality balanced. Whatever I do to one side, I have to do to the other. And 5 minus 13 is -8. So when I graph this, I'm going to put a closed circle at -8, and then I'm going to shade everything above. Notice you always put the arrow at the end of your shading, because this goes on. It includes every number through infinity on into eternity that is greater than or equal to -8. So that arrow helps indicate that we're including all numbers in that positive direction. All right, finally, part C, the difference of P and 14 is less than -9. So I see the word difference and the two values that I'm going to subtract, because difference means subtraction. And usually when you have it written in this way, you can just subtract in order that they come in the sentence. So we could say P minus 14 is less than, so I use my less than symbol, -9. So I've written my inequality. Time to solve my inequality. And then I can graph my inequality. So I'm going to put an open circle at 5, and I'm going to shade everything less than 5 and put an arrow on the ends. All right, last application before you start your homework. This is from page 360, number 31. You have number 32 to do on your homework, so one just like this. You earn points from buying items at an internet shopping site. You would like to redeem 2,350 points to get an item for free, but you want to be sure to have more than 6,000 points left over. What are the possible numbers of points you can have before making a redemption? Write and solve an inequality. So let's identify our key information. But I also know I want to have at least 6,000 points left over. So we want to know the possible number of points I can have before making a redemption. So knowing that I have an unknown total of points, I'm going to need a variable to stand for that. And when I redeem those 2,350 points, they are going to come out of my total, that unknown total. So I'll subtract those out. And when I do use those 2,350, I still want to be sure to have more than 6,000 points left over. So my inequality would say x minus 2,350 is greater than 6,000. And now to solve. Sorry, I had to pause the video and work. I only have 10 seconds. So we add 2,350 to both sides. Here's our inequality. We graph with an open circle and shade above. And now you may begin